Hi guys, this is Himanshu Singhal from Visualpath team, and I will be your mentor during your GCP Data Engineering course. I have around 7 to 8 years of experience in GCP Data Engineering. So, basically, while working with GCP Data Engineering course, no, there are lots of other prerequisites as well. Okay, so let me open the notepad as well. Yeah. So let me make it a little. So, first of all, I would like if you have some basic understanding of Python and SQL. And as you are all are from data engineering or data analytics background, so you might be aware of SQL mostly. If you don't have any Python knowledge, no worries. I will be taking 2 hour session for crash course in Python. Okay, just to go ahead, so that when we will be working with the Python scripting in for the GCP automation, or we can say writing our code, so it will not be very. I mean, it will not be an issue for you. So at the very first classes, we will not be using directly the Python or SQLs. Okay, so that's not an again an issue if you don't have any issue. I mean, knowledge in Python. My 2 hour crash course will work for you, and later on. Meanwhile, our course will be proceeding. You will just learn the Python as well. It is very simple language. Simple. Okay, it's not hard to learn Python. Okay, so it's very easy. So we will be using Python and SQL throughout our course to work for our data engineering task. So basically, while starting with GCP, so first of all, we should know about, like, as you are, if you are aware of AWS or Azure, so there also we have some regions and zones. Okay, so because this is a cloud, and cloud computing, the main idea behind the cloud computing was to introduce the distribution of the data. Okay, because big data was also not a challenge, because there were I mean, we have those big data Hadoop technologies, so we were implementing our all of the pipelines on on-prem systems. But later on, the availability of data was major concern. Okay, because those on-prem systems were deployed on one system only, single system, or we can say in one area. And let's say now a physical crisis or any natural crisis occurs at that area, then our data might be lost, or data may be not available for some time. Okay, so that was the major idea behind the cloud computing. They distributed the data, I mean, or we can say they virtualized the data on multiple across multiple zones and multiple areas. Okay, so those they called as a region and zones. Okay, so if let's say if there is an issue at a particular zone or at a particular region, then our data will be available from another region or another location. Okay, so that's the major thing. So first of all, we will be looking into the regions and zones of GCP, like how many regions or how many zones are available and how they are divided. Okay, then after that, we will be looking into GCP hierarchy, like if you are working with GCP, so how our what we say our resources are available, or how our resources are enabled in our GCP environment. Okay, so we will see that hierarchy, like how they are organized and how to enable whatever required and how to get the things out here. After that, we will look into IAM portal. Okay, or we can say IAM service. So IAM service is something which controls the accesses. Okay. If you want to control the access, obviously, if you are working with data, then data is very crucial part of our data engineering or data science team or data analyst team. Okay. So it should not be be available to all of the users. Okay, the main goal is that. So data security will also be a phase for us to implement as a data engineer. Okay, so using IAM service, we can control the access levels on the data and on the services as well. Okay, services means like the Google Cloud products. Okay, like let's say BigQuery. BigQuery is a Google Cloud product, or we can say Google Cloud service. Let's say Dataflow is again another service. So we can control the accesses on the service level as well and data level as well using IAM. Okay, after learning the access controls, so here we will just learn about the basic IAM services. Why? Because while working with the actual services, like let's say if we will be working with the BigQuery, then we have to implement the row level and column level security as well. Okay, like how to control the data. Like let's say let's take an example. Let's say we have a country and we have another thing like sales. Okay, let's say we have these two columns in our data. Now let's say there are two country data we have like Japan and India. Okay, so Indian people should see only sales from the Indian country only, not to the Japan. They should not see Japan country. So this is something which comes under the row level security. Okay, likewise, let's say there is a quantity column. Okay, so let's say there is a accounting person, or there is another person or CEO level person. They wants to see sales and quantity both. But let's say there is some analyst who just want to see quantity. We do not want him to see the sales of the particular country. Then this comes under the column level security. So these types of things we cannot directly control using IAM service. So in order to in order to control these kinds of accesses, we should be aware of that particular service. Like let's say if we want to implement that into BigQuery, then we should be aware of BigQuery first. Then we can implement the row level and column level security on that. Okay. So we will learn the basics here of IAMs, like how to control the accesses on the user level, service account level. Okay. So we have three kinds of accounts present in our IAM. Okay. So we will look into that, like user account or service account, we can say, and a group account. Okay. Majorly, these three kinds of accounts are available in our GCP. So we will see how to control the accesses on each and every level. Okay. After that, we will first learn about the data lake. Data lake here is the Google Cloud bucket storage, we can see. Okay. So we have a GCS in terms of Google Cloud storage. So this Google Cloud storage behaves as a data lake in our GCP system. So what is a data lake? Data lake can contain any kind of data, any size of data here. Okay, so that's the idea. It can contain the raw format of data. So GCS behaves as a raw data format, or we can say raw data storage, where we can store our data into any format like JSON or CSV or images or videos, anything. Okay, so we will learn about the Google Cloud storages. So here, like in Google Cloud Storage, we have four types of different strategies how we can implement the Google Cloud Storage in our GCP. So we will first of all look into the Google Cloud Storage strategy, like how to, as per our requirement, as per our need, while minimizing the cost as well, how we can implement the optimized data lake in our GCP environment. Okay. Before that, I will also show you Google pricing calculator. So basically, this Google pricing calculator offers you to estimate your pricing while using the GCP. So let's say if you are going to use BigQuery and Google Cloud Storage, but your management asks before implementing everything into GCP or before migrating to the GCP, your management asks like what will be the pricing. Okay, like let's say for 1 month, how much we need to spend. So Google pricing calculator will help you here for estimating your particular costing of the project. Okay, so we will look into the Google pricing calculator as well. Then we will look into data lake. After that, we will start with our database services. So database services, like we have Cloud SQL, we have Cloud Spanner, and we have BigQuery. So basically, these two databases are the relational databases. Okay. So here, like in Cloud SQL and in Cloud Spanner, you will. I mean, we can say these are transactional databases. Okay. So let's say if you are planning to migrate your transactional data, then you will choose either Cloud SQL or Cloud Spanner. Now it will depend on your data size. Like if data is less, or the like frequency of transaction is less, then you will choose the cloud SQL. If you have frequency or the data size great, big, then if you have big data, but it is a transactional data, then you will choose the Cloud Spanner. Why? Because Cloud SQL and Cloud Spanner are the right optimized storages. If you perform any analytical kind of operations in Cloud SQL and Cloud Spanner, it will not be optimized. Okay, it will behave something like, which is, the behavior or the optimization, or the performance of your query will be same as the performance on the on-prem system, because these are traditional relational databases. Okay. Sorry. So these are transactional databases. Then comes our data warehouse, or we can say the analytical database. So BigQuery behaves as a data warehouse and the analytical database in GCP. So here, this particular BigQuery have read read optimized. Okay, so if you are going to write frequent transactions on BigQuery, then it will not be good. It will not behave as a good performance. Okay, it is only read optimized. So if you want to perform analysis on the data, or if you want to perform analytical kind of thing in your data, then you should choose BigQuery. They all can internally connect. Now, let's say if you have a transactional data, but you want to perform the analysis as well on that data while maintaining the transactions as well, then what you can do, you can at the very first layer, or we can say at the raw layer, you can choose the Cloud SQL. You can perform the transactions, and directly you can connect Cloud SQL to BigQuery, and whatever analysis you want to do, you can perform all of the analytical kind of things on the BigQuery, and it will the performance will be good. Okay, so you can perform analysis using BigQuery on Cloud SQL data as well, and Cloud Spanner data as well, without migrating the data from here to BigQuery. Okay, so these database services, we will be looking into them. Cloud SQL and Cloud Spanner are traditional databases. Cloud SQL has three kinds of databases here: MySQL, MS SQL, and PostgreSQL. Okay, and Cloud Spanner is original product of Google. Okay, they created a relational database here. So Cloud SQL is something which is a wrapper, we can say. Wrapper means like it is just built on top of some other SQL engines like MySQL or PostgreSQL or MS SQL. Okay, but this is original development of Google, and BigQuery is a data warehouse. And in BigQuery as well, you can, the format, we can say the structure of this BigQuery is something related to the relational database as well. So you will not find any issues, or you will not face any challenges while working with the BigQuery as well. Your traditional SQL language, SQL commands will work with BigQuery as well. And if you want to write your SQL in the Google SQL, then it will also work. Okay, so these are our database services in our GCP. After database services, we will look into our ETL services. So we have two types of ETL services here: Dataflow, and we have Dataproc. Okay, so after working, after working with BigQuery, so our data will be captured here in these database services. After that, only we can perform the ETLs. Or either if you have the data in your data lake and before storing your data into your target system, if you want to perform ETL, then again you have to go with the ETL service. Okay, so like we have two kinds of processes, ELT and ETL, right? So ELT means like extract, load, and then transform. So if you want to extract and load, and if you want to perform the transformation later, then what you can do, you can just extract the data into Google Cloud Storage, load the data into any of these database service, and then perform the transformation. But let's say before loading the data, if you want to perform your transformation, then that process is called as a ETL. Okay. So we will look into ETL services, which are one more is let's keep it as first. Okay, cloud function. So we will use these three kinds of ETL services: cloud function, data flow, and data proc. Cloud function, we can call it as a simple, we can say, let's say if you don't have any heavy transformations, or you are performing some transformations which are like light transformations, and the data is also not that big, then in that case you can use cloud function. Why? Because cloud function has a limit of 9 minutes, or we can say 1 hour. We will look into it, like when the limit is 9 minutes or when the limit is 1 hour. Okay, so this is the maximum execution time of cloud function. So if you have some transformation which are long running processes, okay, let's say if you are working with streaming pipelines, streaming means the real time data. At that point of time, your ETL service will run 24 into 7 hours. So at that point of time, your cloud function will not be a right choice. Okay, then we will choose either data flow or data prop. So cloud function has a time execution time limit, which is 9 minutes or 1 hour. It depends on situations. We will look into it when we will be working exploring the cloud function. Okay. Then another ETL service is Dataflow. Dataflow is based on the Apache Beam. Apache Beam is a open source framework developed by Google only. So this Apache Beam is a is like Spark. Okay, Spark is a distributed framework where you can write your pipelines, and your pipeline will work in the distributive. It will take advantage of distributive computing. Okay, so Apache Beam is something same. So this data flow requires an understanding of Apache Beam. So before going into data flow, we will look into Apache Beam very deeply, very deeply. Why? Because if you don't know the Apache Beam, then you will not able to write the pipelines using data flow. So after this cloud function, we will work with data flow. So for data flow, we will first of all work with Apache Beam, and then we will start with the data. Okay. After that, we will start with data proc. So data proc is something which is like based on the Spark. Okay. So data proc. So let's say now when to choose data flow and when to choose data proc. Okay, so if you are very new, and if you have if you don't have any traditional systems, or your traditional systems do not have any pipelines written in Hadoop or Hadoop ecosystem, we can say. Okay, then in that case you can choose data flow. At the very first point of time, data flow, you will find challenges in writing data flow code, but this is more cost optimized than data proc. First of all, second thing, data flow is 100% serverless product. You do not need to take care about any working with any of the server related things, or you do not need to manage server here. But if you are going with data proc, then you need to take that overhead to manage the server. Okay, so if you are migrating your Hadoop ecosystem directly to BigQuery, then you should choose data proc. Otherwise, you can choose data flow. Okay, so this data proc is completely based on Hadoop ecosystem. You can write your pipelines in Hive, Spark, or PySpark. anything. Even you can just migrate your clusters here, and whatever pipelines we have written for on-prem system on your Hadoop ecosystem, no, so that will be you can directly use without modification in the code. You can directly migrate that pipeline to Dataflow. You just need to modify the source and target. That's it. Okay. So these are our ETL services which are present in our GCP. Apart from it, we have one more, Cloud Fusion. So Cloud Fusion is a no code environment, no code we can say, or less code environment. So here in all of these three ETL services, you need to write code to work with. But in Cloud Fusion, you do not need to write any code. You just need to create the connectors. You just need to drag and drop the transformations, and that's it. Okay. So here you cannot perform any I mean, if you want to do some custom transformations which are not present in Cloud Fusion, then you cannot perform that here. You need to go with Dataflow, Dataproc, or Cloud Function there at that point of time. Okay. But if you are having traditional, I mean, we will see the Cloud Function as well, Fusion as well, like what transformations it has to provide us. Okay. So so these are our ETL services which we will be covering throughout our GCP data engineering course. Then we will go with orchestration service, and we have Composer. So Composer is something which is built on top of Airflow. If you are using the Apache Airflow is a open source orchestration platform. You can deploy Airflow in your on-prem systems as well, and you can orchestrate your on-prem systems as well. Okay. So what Google developers did, they just took Airflow and they created a platform on top of this Airflow, which they named as a Google Cloud Composer. Okay, so we will see orchestration service as a composer, which will be used to orchestrate all of your pipelines, whatever pipelines or anything related to GCP. If you want to orchestrate your IAM services as well, like let's say if you want to automate your user level accesses or service account accesses, you can do that using Composer. If you want to control the BigQuery ingestions, you can use Composer. If you want to control Cloud SQL or Cloud Spanner ingestion, you can use that. If you want to control like how Cloud Function will be triggered or Dataflow, Dataproc will be jobs will be triggered, you can use Composer. Okay, so Composer is the key service which will be which I mean, if you are working with any of the organization, you will find two components very common, which is BigQuery and Composer. It depends on the organization. It depends on the organization use case whether they want to use another other services as well. But you will always find BigQuery and Airflow in action there, or Composer in action there. Okay, so we will be working with Composer for orchestration. Then we will look into scheduler service, which is a cloud scheduler. So let's say if you have if you have so this orchestration service, orchestration means automating anything. You can control automation of anything in the cloud. But cloud scheduler is something different. Cloud scheduler is something which can automate one-time triggers. One-time triggers, let's say if you have created an API, and let's say you want to trigger that API at some point of time, let's say every day at 8 a.m., one API should be triggered. If you want to do that, then you can use Cloud Scheduler. Okay, because it is not fully developed service. It is just something like a cron job. Okay. If it is failed, you need to re-trigger it again. But in Composer, it depends on the DAGs. We can say DAGs. Okay, directed acyclic graph. This is not a DAG. This is just a cron service. And Airflow, like it, I mean, this Composer contains multiple tasks. Let's say if pipeline fails at a particular point or at a particular task, then you do not need to rerun all of the pipeline. You can just re-trigger that particular task at the same point of time. Okay, so it saves your overhead to re-trigger all of the pipeline and everything. Okay, but it is a cron job. If it fails, you need to re-trigger everything. So we will look into Cloud Scheduler as well. mostly what happens, cloud function and cloud scheduler. I mean, what architects prefer, or what I mean, depending on the use case, mostly cloud scheduler plus cloud function work in an action. Okay, because we want to automate the cloud function as well. So if you are writing your pipeline in cloud function, then you do not need to use cloud composer, because if you are writing a cloud function, it means your use case is very small, or you are not using that much computing power. Then in that case, you can just if you want to automate cloud function trigger, you can just use cloud scheduler, and that's it. Okay, so it depends on the organization, like how they wants to save the cost and how they want to work with. Like, let's say in my previous organization, they were not using Airflow. They were using only cloud scheduler to trigger the data proc jobs. You can trigger the data proc jobs, you can using cloud scheduler. It will be more cost optimized. But the issue is, if at any point of time my data proc job fails, then I need to re-trigger whole job. Let's say 3 tasks are completed, but still I need to rerun those 3 tasks. Okay. And in my current organization, what we use Dataflow and Composer. We use Dataproc as well. So using Composer, we just orchestrate our pipelines in Dataflow. So it depends on your organization. Okay, cloud scheduler is it doesn't cost you more, but cloud composer costs you more, because this cloud composer contain a web server, execution server, trigger, and then database. These four major components involved here. So all you have to pay for all of the components. In cloud scheduler, it is just a single computing service. Okay, so you do not need to pay more here. Okay, but you have less control over your jobs, and here you have more control of over your jobs. So that depends. Okay, so after learning the scheduler service, what we will do, we will go into computing service, which is compute engine. Compute engine and app engine. Okay, so what you can do, if you do not want to use any of these services and you want to set up something like on-prem kind of structure in your GCP as well, you can use computing services. Okay, so these two kinds of computing services are there: compute engine and app engine. So we can leverage these, and we can use these services for our fulfilling our desires. But here you need to manage the servers. All of these services, sorry, cloud SQL is the Google managed computing service, or we can say database service. Google managed means it is not 100% serverless. Okay, but it is 50% serverless. You just need to take a slight control over your cloud SQL instances. Okay, Cloud Spanner and BigQuery are 100% serverless instances. Again, these two are 100% serverless. This is 50% serverless, something like that. So depending on your situation, you can choose. And if you are choosing to set up on-prem kind of system on GCP, then you can choose compute engine or app engine. Then you need to manage the servers as well. Okay, these are not the serverless engines. Okay, so this, then after that, what we'll do, we will work with security. Okay. So in this security part, we will work with RLS, CLS, and then data loss prevention. And yeah, so most of the things, these all three features will fulfill our data governance and security. So we will work with these kinds of principles to implement in GCP. DLP is something which is another service, data loss prevention API. Okay, so using this DLP API or DLP service, you can encrypt your data. Okay, using some templates. This provide us some templates, or we can create our custom templates as well in DLP to encrypt our data. Encrypt our PII data mostly. When while working with PII data, then only we use DLP mostly. Okay, so this is the data security, and then we will also use secret manager and what we say, encryption keys. Okay, So secret manager is something where you can store your secret data. Let's say you want to store username, password to connect with any of the on-prem database or any APIs or something. So there, those kind of data you can store into your secret manager. And encryption keys is something using which, so basically in GCP, you can encrypt your data using either Google provided encryption keys or customer managed encryption keys. Okay. So Google provided encryption keys. In that case, Google will manage the encryption key and they will encrypt the data and decrypt the data as per your need. But if you want to manage your encryption keys as well, then you can use encryption keys that is called as customer managed encryption keys, and you can provide the key, I mean, public and private key to encrypt and decrypt your data. Okay, so we will look into these security principles here. Okay, so this is our major services which we are going to cover throughout our GCP data engineering course. Okay, so you can see I am right now into my dummy console. I don't have an active account right now. I will be looking. I will get the actual account in 1 or 2 days from Visualpath. But let's see the products, like all of these products. Okay, so we have API. So first of all, let's take a break here. If you have any questions, cool. So we'll be looking forward for you in the next batches.